Yeah, good morning. Welcome to this session on equilibrium. Okay, let us understand what is equilibrium. Okay, in engineering mechanics. So first, I'll go with what is equilibrium. Second one, what you can do with this. Okay, so these two questions we'll see today, right? So it's a equilibrium is related to the force and a rigid body. uh, if you talk in terms of engineering mechanics, the first year level of engineering, okay. So you know that the engineering mechanics is a study of the rigid bodies under the action of forces. Okay, so then what is equilibrium? Okay, so if you say if the resultant action of the force system acting on a body is zero. The body is said to be in equilibrium. Okay, so this is how we define and how we understand what is equilibrium. Okay, you see this? A resultant is zero in simple words. Okay, if the resultant is zero, okay, resultant of what? Of any force system acting on the body. Okay, so you know the physical world, we have the bodies consisting of so many forces acting, and we have categorized them into so many force systems. Okay, you just see the videos know which I have done on the force system. Okay, so this is what the answer for what. Okay, so if the resultant action of the force system acting on a body is zero, then the body is said to be equilibrium. Okay, then going back to the second question, what you can do with this? We do two things. One is we verify whether the given body is in equilibrium or not. It is one way of doing it. The other way, we'll find unknown forces. So, preferably the reactions, what you call. Okay. So, these two things we do. We verify the equilibrium, means what? If you are given a body and there are some forces acting on it. Okay, so we see that whether the body is in equilibrium or not, means the resultant of that is zero or not. The other thing what we do, if you know that the body is in equilibrium, then with the conditions, equilibrium conditions, we find unknown forces, that is reactions. Okay, so these things we do with the equilibrium concept. Okay, yeah. So we go for a coplanar system. Okay, we restrict our discussion to coplanar system. So imagine you have a collinear force system. Okay, acting on a body. Say, I'll just draw the forces acting on this body that I have taken. So, for example, something like this. Okay, so all these are on a single line of action. Okay, so that is what you call collinear force system. So this is something like P1, P2, P3, P4, P5, like that. So if I find the total force value, if I get zero, sum of all forces is equal to zero. Okay, then I say that this body is in equilibrium. Okay, so this is how you verify the equilibrium of a coplanar collinear force system. Okay, then let us talk about concurrent force system. Concurrent force system. So consider a body where all the forces are acting at a single point, something like this. Okay, let us say these are all P1, P2, P3, P4, P5, P6, something like this. All the forces are passing through this point. So this is a concurrent force system. Okay. So how do you find resultant of this one? Resultant, we'll find sum of x forces, okay, whole square, sum of y forces whole square, like this. Okay. So your definition for equilibrium of this body is resultant shall be zero, right? So if resultant shall be zero, I need sum of x forces to be zero and sum of y forces to be zero. So these two are what we call equilibrium equations. Okay, equilibrium equations. So the condition is resultant shall be zero. This is the condition for the equilibrium of the body. Okay, so if concurrent force system act on a body, for resultant to be zero, it shall satisfy these two equations, which are nothing but the conditions, the two conditions. Sum of all the x forces shall be zero, sum of all y forces shall be zero. Okay, if we talk about in terms of rectangular components. Okay, yeah. Going for the next force system, which is a non-concurrent force system. Non-concurrent and non-parallel. Okay, so what you call, it's a general force system. So if this force system acts on a body, let us say consider a body. So now you have forces, okay, which are not parallel and they do not pass through a single point. Okay, so they are not parallel and they are not concurrent. Okay, so now how you find the resultant of this one? Again, sum of x forces, sum of y forces, and the resultant will be square root of sum of x forces square, sum of y forces square. So for resultant to be zero, x forces shall be zero, y forces shall be zero. Then what is the difference between this and the concurrent force system? See, there is a case of a couple formation in this case. These forces may form a couple. Okay, so where couple means what? Equal and opposite forces separated by some distance. So take sum of forces zero here. Yes, it is zero. But what you have, moment is not zero. This will generate a moment. Okay, so because of the moment, the body will be trying to rotate it. Okay, because of the moment, body will try to rotate. Okay, so to stop this rotation, you must also ensure that moment is also zero. Okay, so that is the difference between the concurrent force system and non-concurrent force system. Okay, so here you need to check three conditions. Sum of x forces shall be zero, y forces shall be zero, and the total moment generated by all these forces about any point shall be zero. So these are the conditions, nothing but equations turned into equations. Okay. So this is how you check the equilibrium, or if you know the forces, if there are supports given to your body, you can find the unknown forces in the system. So this is what the equilibrium means. Okay. So equilibrium means finally a resultant shall be zero of what? Of a force system acting on a body. So, and we have seen the various force systems and what are the conditions to be satisfied. For collinear force system, just one condition and one equation. For concurrent force system, the two conditions and two equations. For general case of force system, three conditions and three equations. Okay, so this is what a detailed discussion on what is meant by equilibrium. Okay, thank you. We'll be back with some other topic.